a lot of the content we see today talking about percents may be something that you've seen before. You may be very comfortable with most of it. And that's okay. That's not a bad way to start out after an exam, is to start out with something comfortable. But just in case, we are going to go through a little bit of a review, so a little bit of an introduction to the idea of percents. The first thing is, what even is a percent anyway? And it's right there in the word. Percent means per hundred. If you look at the word cent, there are 100 years in a century. There are 100 cents in a dollar. And so cent is a root word that lends itself to 100. And so percent is per 100 or out of 100. If we were to say something like 42%, what we're saying there is, okay, that's 42%. That's 42 per 100. That's 42 out of 100. And if we wrote that as a fraction, 42 out of 100. Okay. And then if we wanted to rewrite this 42 over 100 as a decimal, we just divide 42 divided by 100, and we could see 0.42. So there are three different ways we could write this number. We could write it as 42%, 42 over 100, or 0.42 as a percent, as a fraction, as a decimal. Any of those would be an acceptable way to write that number, 42 out of 100. A little bit more review of this, just to kind of talk about going back and forth between percents and decimals. Let's say we just start out with a fraction that is 1/2. What would that be as a decimal? Somebody pop that up there for me. I haven't asked y'all to type anything in a week. It feels like I need to. What would that be as a decimal? Perfect, Zara. Perfect, Riley. Thank you very much. 0.5. And you guys will see me put 0.5. It's if you just put 0.5, that means the exact same thing. They are both equivalent to each other. There's no one, it's not like one of those is right and one of those is wrong. I tend to do the 0 just because, especially in this format, you might not see the little decimal point that I make. And so by putting the 0 there, it just makes it obvious that there's a decimal point. But it's perfectly fine to write it the way that Zara and Riley did there in the chat. And so 0.5 for 1/2. And if I wanted to write it, if I wanted to go to the hundredths place, just because I know percents are about hundredths, so we could put 0.50 just to make it go to the hundreds place. Again, 0.50 has the same value as 0.5, so we haven't changed the value. We've just taken it to the hundredths place. And then as a percent, this would be 50%. And you're probably very comfortable with this. I probably didn't need to write it down. But when we go back and forth between percents and decimals, a lot of people remember it as, I just need to move the decimal point 2 places. And that's good. There's nothing wrong with that. These are really easy to remember, 0.50 and 50%, to sort of which way does the decimal need to go. And we can see that when we go from a decimal to a percent, the decimal point moves 2 places to the right. And then in reverse, if we go from a percent to a decimal, the decimal point was here, it needs to move 2 places to the left. And if you ever find yourself sort of mixed up about, gosh, which way does it go again? Well, if you just sort of lean back onto this one, well, I know 50% and 0.50 are the same as each other. Oh, okay. That means if I'm going from percent to decimal, I need to move the decimal point 2 places to the left. And so it's just a kind of a way to help remember by having a nice little anchor point to hold on to. 50% and 0.50 can be that anchor point. A little bit of practice. If we want to convert the decimal, 0.27 to a percent. So now we're going from decimal to percent. Some of you will do this by saying, well, you just move the decimal point 2 places to the right, and it's 27%. Outstanding. Nothing wrong with that. That's perfect. Others might say, well, let's see. If I were to write this as a fraction, it would be 27 hundredths, because percent is 27 out of 100. Oh, and so how many out of 100 is this? Well, it's 27 out of 100, so it's 27%. You could also rewrite it as a fraction like this, and then just divide that on your calculator. Oops. We don't want to divide that on our calculator. 27 out of 100 tells us 27%. Dividing on our calculator is going to happen the other way. If we want to convert 34% to a decimal, okay, 34%, that's, some of you will say, well, to convert that to a decimal, I just move the decimal 2 places to the left, so it's 0.34. Perfect. Excellent. That's great. Others might say, well, 34%, percent means out of 100. Now I have this fraction, and now I can use my calculator to divide this, 34 divided by 100, and I end up with 0.34. Essentially, we're going to go back and forth between decimals and percents quite a bit, and I want to make sure you're comfortable taking a number that's a decimal and making it a percent, and taking a number that's a percent and making it a decimal. Does anybody have questions on that before I have you try one? Okay, outstanding. Here goes. Convert 4% to a decimal. I'm going to make a poll for this. It'll probably take me longer to type the poll than it will for you to answer it. That's okay. And this one's pretty quick, going percent to decimal. We'll go another 15 seconds, and then we'll talk about it. All right, let's see where we are. Awesome, unanimous. Nobody fell for the obvious hurdle in this one. The hurdle in this one is that you might just sort of casually go 0.4 because it's 4%, but keep in mind that would be 40%, and we don't want that here. Instead, we want to convert 4% to a decimal. We have 4%. We'll move the decimal 2 places, and we'll end at 0.04 would be 4%. 4 out of 100, we wouldn't want to do 4 out of 10. Great job on the poll. That's awesome. That lets me know we're really comfortable with that, which is terrific. Okay, some percent problems that we're going to look at. Types of problems that we can see involving percents. We are going to take these words and translate those into equations that we can work with. And here's how that's going to go. When we look at that first one there, and it says, what is 56% of 310? The first thing we see here is what? Well, that's the thing I don't know, so we'll call it X. Is, what's a math word that would go with is? What's a math word that, if I'm going to translate this from words into math symbols, what's my math symbol for is? Very good, Lorraine. Is equals. Yes. 56%, we're going to convert that to a decimal so that we can work with it here. Of is an important word for us. Of is a word that is going to tell us to multiply. So of tells us multiply. 310 is just 310. And so what we've done is we've translated this from words into an equation that we can work with. What is 56% written as a decimal of, which is multiply, 310? The only thing we need to do to get x by itself here is just actually multiply those together. That 0.56 times 310 is 173.6. The instruction said round to the nearest tenth. This already is, so it's done. What is 56% of 310? 173.6 is. Let me know if you have any questions on what we did there. Up next, we're going to work on the one at the bottom. Okay, very good. So looking down here, we start out with 22 is what percent? This is the thing that we're looking for, so we'll call that x. There is one little caveat here, though. We have to kind of remember when we get to the end of this one that we're being asked for a percent. So we want to make sure we report the answer as a percent. The what percent, that is what we're looking for, but we're after a percent. We need to keep that in mind. All right, then we have of, which is our multiply, and 70 is just 70. So 22 equals x times 70. We don't do a ton of algebra, so just as a reminder, this is 70 times x. What am I going to do to make that multiply by 70 go away so that I get the x by itself? What am I going to do to both sides? Excellent, Genesis. Thank you. We're going to divide, and we are going to divide by 70 on the right so that these cancel, leaving just the x. If we divide by 70 on the right, we have to divide by 70 on the left. And I don't know what I'm going to get on the left, some decimal of some kind. 22 divided by 70 looks like 0.314285, and it keeps going. And that's x. And so I took this problem that I was given, I turned it into an equation, and then I solved that equation. So kind of feels like I'm done here. But then I'm going to look back and say, wait a minute. This was asking me for a percent. So I don't want my answer to be a decimal. I need to turn this decimal into a percent. To do that, we'll move the decimal point 2 places, and I'll have 31.4285, and that keeps going, percent. Finally, the last thing we'll do here is round the answer to the nearest tenth. So we'll find the tenths place, we'll look one space to the right. That number is 4 or lower, so we'll round this down to 31.4%. So 22 is what percent of 70? It's 31.4% of 70, about a third of it, which makes sense. The one at the bottom of the page, significantly more work than the one at the top, but the idea is the same. We start out with some sort of question that we've been posed, we translate that to an equation, and then we do whatever we need to do to find out what x is, the thing we're looking for. Same idea down here. We start out with words, we turn that into an equation, and then we do what we need to do, be a little flexible. Here we had to divide by 70, realize that this decimal need to be converted to a percent, and then round correctly. Are there any questions on either of those two before I have you try one? All right, here goes. 118 is what percent of 275? Round your answer to the nearest 10. I'll set up a poll for this one and give you a chance to try it. This is the kind of question you could expect to see on a quiz or an exam. Um, and the homework problems in our book are, designed to sort of push you towards this sort of setup. They don't always use the is and what and of, but a lot of them do. Um, and often, even if a question doesn't explicitly say is, what, and of, you can kind of see in the question that that's what it's really asking you for. 118 is what percent of 275, even if that's not exactly what the word said, you can see that that's where it's pointing you. And then you can set up your equation and solve. We'll go another 30 seconds and then talk about it. Let's see where we are on this one. All right. Not unanimous, but really strong agreement. That's terrific. Very good. All right. We're having a really good start on percents. That's awesome. Okay. Let's talk about this one. Let me know if you have questions when we go through it. So we start out translating. 118 is what percent? That's the thing that I'm looking for. And I make a little note to myself that my answer needs to be a percent of 275. We're trying to get that x by itself, so we need to get rid of multiplication. So we're going to divide, and to get rid of that 275, we're going to divide by 275 on both sides. On the right-hand side, they cancel, leaving just the x. That was our whole point of doing the division in the first place, was to get x by itself. And then on the other side, we have whatever 118 divided by 275 is. It looks like 0.4290. 90, and that keeps going. Here we have an answer, but it's a decimal answer, and we need to have a percent answer. So we'll move the decimal point 2 places and have 42.909, and that keeps going. Now it's a percent. Finally, last but not least, we're going to round to the nearest tenth. We'll find the 10th place, look one space to the right. That's 4 or lower, so we'll round this down to 42.9%. The poll went really well, but if anybody has questions on this or you don't see exactly how something happened, please don't be shy. Make sure you ask. All right, let's go through some problems that a little more real world situation that involve percents. Yvonne spends 36% of her income on rent. If her rent costs $1,200 per month, what is her monthly income? A couple of minutes ago, I mentioned not every problem is going to be exactly a what is of type of question. You might have to get there from where you are. And this is what I meant by that. Nowhere in here does it say what is of exactly, but it kind of does if we read it carefully. We can see here that she spends 36% of her income is rent. So what this says is 36% of her income is rent. Okay, now we kind of have this what is of, because what we're looking for, what we're trying to find here, what is her income? That's the thing we're looking for. So there's sort of this intermediate step where I go, all right, here's what you gave me. I'm going to rewrite it in that sort of what is of type of format so that now I can write it as an equation to solve. 36% we'll write as a decimal. Of is multiply income. That's the thing I'm looking for here. Is, and rent we were told was 1,200. So it took an extra step for me to get to my equation because I wasn't really given a what is of question. I was given sort of some real world situation that I had to sort of figure out, okay, what is it you're really asking me here? What is it the equation I'm really setting up? And it's, okay, if 36% of her income is paid to rent, then here is the equation I can set up and then solve. Just like we've seen in the past, if I have multiplication, I need to divide to make it go away. So I'm going to divide by 0.36 on the left. That'll get these to cancel and leave just the x. If I divide by 0.36 on the left, I'm going to divide by 0.36 on the right. What that does is that leaves me just an x on the left, and 1,200 divided by 0.36 is $3,333, and then a whole bunch of threes repeating. It says, what is her monthly income? And I can see it there. And nowhere in here did it tell me where to round. I did that on purpose for this one, because if you don't get any instruction on where to round, and that would be rare, that would be unusual, but if you're not given instructions on where to round, and the problem involves money, like this one does, then we're going to round to the nearest cent. That's going to be sort of our default. If there's nothing in there that says, then we're going to round to the nearest cent. Dollars and cents, we're going to round to the nearest cent, which means we're going to round to the nearest hundredth. So if a problem involves money and you're not told where to round, your automatic default is the nearest cent, which means the nearest hundredth. So here we'll find the hundredths place. We'll look one space to the right. That's 4 or lower. So we'll round that down and see that her monthly income is $3,333.33. Does anybody have questions on what we did there? Basically, we had to go one more step to set it up in the what is of structure. All right, you try this one. Philip and Elizabeth just finished a meal, and the cost was $48.20. What would be the amount for a 15% tip? I'm going to set up a poll for this one. Essentially, what you're trying to do here is find out how much they should tip if they want to leave 15%. We'll go another 15 seconds on this and then talk about it. All right, let's see where we are on this one. Okay, again, really strong agreement. Very good. Okay, if you see anything you're not sure of, make sure you ask about it. Please don't be shy. Here we go. I know sometimes when everybody's getting everything right, you feel like, oh, I don't want to be the one to ask. You know what? It's possible that they got lucky, they picked the right one. Who knows? If you have questions, ask them, and please don't be shy about it. Yes, we're doing really well on these today, but if there's something that's not making sense for you, please don't be shy about asking. Okay. So Philip and Elizabeth just finished a meal and the cost is $48.20. What would be the amount for a 15% tip? And so again, you don't have to do this step, but sometimes students find it helpful to say, all right, what is this really asking me here? This is saying what is 15% of that total meal? So it's what is 15% of 48.20? That's kind of what the question is here. And this is, again, that intermediate step. You don't have to write it down this way, but you can if it helps you to get it in that sort of, and it's not really called this officially. It's just something that I've always said, that what is of sort of structure, because now we can go ahead and write our equation where what is the thing I don't know is 15% of $48.20. And so some of you may have seen right away, well, you just multiply the two. Fantastic if that works for you. Others might go straight to here and have this equation set up right away. Great if that works for you. Others might want this step first, and that's okay too. The approach you take to solve these correctly over and over again, that's the best approach for you. Last thing we need to do here then is multiply 0.15 times 48.20, and we wind up with x is equal to $7.23. And so a 15% tip would be $7.23. Let me know if you have questions. And we're going to continue with some of these, real world percent type questions. A pair of earbuds costs $24 and the sales tax rate is 8%. What is the total cost of these earbuds? So the first thing we have to find out here is how much tax is going to be paid. How much sales tax is going to be paid? And that'll be really what we're saying there is, what is 8% of $24? And again, you don't have to write it out that way, but you might find it helpful, and that's really what's being asked. If we're figuring out how much tax there's going to be, what is 8% of $24? Well, now that I know that's what I'm after, I can say, what is 8% of $24? And we can see that we're just going to multiply those together. This is very similar to the last one that we did related to tips. 0.08 times 24 is $1.92. Here's the danger in a question like this one, because my sense is that you'd be pretty comfortable doing everything we've done so far. Here's the danger. The danger is always make sure you answer the question that's being asked. And this question said, what is the total cost of these earbuds? It did not say, how much sales tax will you pay? If it said how much is the sales tax, then $1.92 is our answer and we're done. But it didn't. It said, what's the total cost? And so we've got just a little more work to do to find the total cost. And that's going to be the $24 that we started with, plus the $1.92 in sales tax, to be $25.92 will be the total cost of the earbuds. So this is one of those, it's just sort of a little red flag that I wanted to send up, that make sure you answer the question that's being asked, because I can be guilty of this too. I read a question, I go, okay, this is a what is of, which means I can rewrite it as an equation. I solved that equation, so I must be finished. And then just take that one extra beat and go back and say, wait, what did this ask me for again? Oh yeah, what's the total cost? So I'm not done yet. I've got one more thing to do here to get the total cost, and that's add the original price plus the sales tax together. Hopefully that makes sense. Um, I understand that if you're taking a quiz or an exam and you put the $1.92 and you get it marked wrong, it's really frustrating. So I hope that never happens. Make sure just to take that one extra beat and go back and say, wait a minute, did I answer the question that was being asked? Any questions on this one before I have you try another? Awesome. Here goes. A phone sells for $800 but is on sale for 30% off. What is the sale price of the phone? I'll set up a poll for this. You can try it. And we don't have to be in a hurry at all. This is one of those lessons that is going quicker and simpler than I imagined. So it'll be a relatively we don't have to be in a hurry, I guess is what I'm saying. There's not a ton of content left for us today, and we've gone through it pretty quickly so far. So that's awesome. We'll go another 30 seconds and then do this one. Let's see where we are on this. Strong agreement, not quite as unanimous as before in a lot of the problems, but that's okay. There's one common thing to do incorrectly here, and that's the thing that happened to a couple of those responses. So let's go ahead and take a look. So the question says, a phone sells for $800, but it's 30% off. What's the sale price of the phone? And it's sort of natural. The first thing we're going to find here is how much is the discount? And the discount is really just saying, what is 30% of $800? We know how that goes. What is 30% of $800? And we'll multiply those together. And when we do that, 0.3 times 800, we get $240. 240 is a really important part of our solving process because that's the amount of the discount. That's how much they're going to take off the price of the phone. Kicker is when we go back and look and it says, what is the sale price? So I'm not going to pay $240 for the phone. That's how much they're going to take off the price. That's the amount of the discount. The sale price then isn't going to be 240. Instead, it's going to be, well, the original price was 800. If I subtract 240, which is my discount, now I land at $560, and that's going to be the sale price of the phone. That's how much I'm going to have to actually pay. 240 is a really important number here because it's how much they're going to take off the price. But the answer to our question, what is the sale price? That's 560 because it's the resulting price of the phone after the discount has been taken off. Very good. That's awesome. Oh, good. Well, the next one will feel very real to you when we look at this next example. Um, the bookstore markup on a book is 20% of the price they pay to get the book from the publisher. And just sort of an example of what, that idea of markup is, the bookstore's a business. They buy the book from the publisher and then they increase the price by a certain amount before they sell it so that they make a profit on the book. So that's the markup that this is referring to. Whatever they pay the publisher, they add something to that in order to make a profit. And so if a bookstore markup is 20% of the price they pay to get the book from the publisher, if the cost of the book at the bookstore is $65, what did the bookstore pay to the publisher for the book? Now, this is a little more involved than what we've been working on so far. I don't think it's overly challenging. I don't think you're going to have too much trouble, but we want to think this one through a little more carefully. It's not as straightforward as a straight into a what is of setup. So the bookstore markup is 20% of the price they pay to get the book from the publisher. So what that is then is whatever the cost from the publisher was, because that's what we're trying to find out here is what did the bookstore pay to the publisher? Let's just call that P. That's what they paid to the publisher. So what we're going to do then is, okay, here's what the bookstore paid to the publisher, and they are going to add 20% of that to the cost. And then after they've done that, right? So they get the book, they paid this much for it. They add their 20% of the price as a markup. And then once all that's done, the cost at the bookstore for the person who's going to buy it is $65. And so we can say that, okay, we take whatever they paid to the publisher, we add 20% of that on top, and then when that's all done and they put it out there for sale, the cost is $65. So just making sure you see where this came from. We have the price from the publisher, we add that 20% of that price that's the markup, and once we add those things together, that's what gives us the price that it's going to sell for. If anybody is unsure of where what I have so far came from, please ask about it. We're going to go from here, all the way through to the end. The hardest part is over now, honestly. All right, awesome. Okay. Yeah, if you're comfortable getting to here, then I think you're going to be just fine with these. I might be wrong. You can ask questions if you have them. But okay, so now I have P plus 20%. Times P is 65. And now it's algebra again, sort of gentle algebra over here. I have like terms. I have P plus 0.2P. Does anybody remember if we don't have a coefficient in front of a variable, what number is actually there? Like, what number would be here if I was going to write it down when I don't put a coefficient? Excellent, Zara. Very good. If I don't put a coefficient, that means there's a 1 there that we don't write because multiplying by 1 doesn't change the value, so we don't bother writing it there. So now what I have on the left-hand side here is I have 1p plus 0.2p. And then when I add those together, what I have on the left-hand side is I have 1.2p. And that's still equal to 65. So what I did is I have 1p, I have 0.2p. When I put those together, I have 1.2 times p. And now we're kind of home free. Now we say, all right, then, if 1.2 times P is 65, in order to get P by itself, we're going to divide by 1.2 on the left, divide by 1.2 on the right. Those are going to cancel, leaving me with just P. And then 65 divided by 1.2 is, I'm going to round this to the nearest cent since it's money, 54.17. And so what did the bookstore pay to get the book? They paid $54.17. And then in order to have their 20% markup, when they sell it for $65. One thing I want to emphasize here is what we did not do. And you can just kind of listen to this. You may or may not want to write it. What we did not do is find 20% of $65. We did not do that. And the reason is because when the bookstore adds their markup, they're adding that markup based on what they paid for the book, not what a student pays for the book. So 20% of 65 is not a part of this process at all. Instead, we're trying to figure out the number that they took 20% of in order to make their markup happen. We're not doing 20% of 65 because this isn't what they paid for the book. It's what they're actually selling the bookstore after the markup happens. I hope that makes sense. And if it doesn't and you want me to say it again, you can let me know that. The key is make sure you approach a problem like this by setting up your equation and solving rather than just using the numbers you were given, because nowhere in this one do we take 20% of 65. Okay, awesome. You try one. A television is 15% off and the sale price is $800. Rounded to the nearest cent, what was the original price? This is very similar to the one we just did. There is one little difference though. Instead of a markup that gets added to the price, this time we have a 15% discount and we're trying to find the original price. So, um, so this may prove to be a little challenging. We'll see, because it's not exactly like the last one, but it's very similar. We'll see how this goes, and we'll talk about it together in a couple of minutes. The structure here is like the last one, though. We don't know what number the discount was taken on, and that's what we're trying to find, the original price. And you've heard me say this before. If you come up with an answer that's none of the ones showing, and you can pick the one that's closest to it, just so I know you've had enough time. I do think this one's pretty challenging as I think through it. It is a lot like the last one, though, with one little difference, but it's a really important difference. We'll go another 30 seconds and then talk about this one. Okay, let's see where we are on this one. Okay, we hit one that was tough. All right. Well, in a way, that's a good thing that we hit one that was tough today. I when I read the question, I'm thinking, this is going to be tougher than I thought it might be. All right, let's go through this one together, and you let me know if you have questions as we do. So we're told here that it's 15% off, and the sale price is $800. We want to know what was the original price. How this is similar to the last one. The last one, there was a markup. So we didn't know what the bookstore paid for the book, and then they marked it up 20% to get the sale price. We wanted to know what was the original price. There was a mark up. This time, there's a mark down of 15%. So we don't know what the original price was. Again, we'll call that P. And this time, I've got P, the original price. I'm going to subtract 15% of that original price because I'm taking 15% off of the original price. And then I end up with a new price that is $800. It could be that setting up that equation made perfect sense to you, and it's exactly how you did it, and that's fantastic. If not, I want you to see the similarity to what we did in the one before it. In the one before it, we don't know exactly what they paid to the publisher for the book, but we know they added 20% to get the price that it went out for sale. And this time, we don't know what the TV cost originally, but we know that they subtracted 15% of that price to get this new price that they put it out there for sale. And so now we have this equation. And my hope is that getting to here is the hard part. And after this, you're home free. If that's not true, you can let me know. From here, we can kind of start working through it. I'm going to go ahead and convert that 15% that was the discount to a decimal. So we have P minus 0.15 times P is 800. And like we talked about in that last one, I don't have a coefficient here, so there's a 1. So I have 1P minus 0.015P. Okay, well, adding was simple enough. The 1 plus the 0.2 just made 1.2. Subtracting, I'm going to use my calculator here. 1 minus 0.15. Okay, that leaves me with 0.85P is equal to 800. Hopefully that makes sense. If not, you can ask about it. Some of you who are really comfortable with all of this might be able to look at this immediately and say, well, that makes perfect sense because you took 15% off. So this new price is 85% of the old price. And that's exactly what's happening here. And so if that helps you make sense of it, then that's excellent. Fantastic. All right. Then to get P by itself here, we'll just need to divide by 0.85 on the left, divide by 0.85 on the right. Those cancel, leaving just a P on the left. And when we divide 800 divided by 0.85, we get 941.18. This one's harder because of the subtraction just isn't as comfortable right out of the gate as the addition was, but the idea is exactly the same. When we have a markup and we're looking for the original price, we're going to have the original price plus something, and we're looking for that original price. Here in Markdown, we have the original price minus something, and that's how we find out what the original price used to be. Hopefully that helped clear that up. If you have questions, if there's something that you're unsure of, don't hesitate to ask. Fantastic. All right. One more thing to look at today. It's relatively straightforward, but something that's not always obvious. A television production assistant starts out making $31,000 per year. This person will receive a 3% raise after the first year and a 5% raise after the second year. Are they making the same as they would if they originally just received an 8% raise? So I guess the question really being asked here is, well, they're going to get a 3% raise and then they're going to get a 5% raise. Is that the same as just getting an 8% raise? What's your instinct? And I'm not going to do a poll for this. I'm just curious, yes or no. What's your instinct? Is a 3% then 5% the same as 8%? And this one, you know, we're going to do the calculation. I'm just curious what your instinct is. That's funny, Lorraine. I like it. Okay, a couple of yeses for instincts. Oh, and you know what, Lorraine? I kind of think that you've hit this one on the head, actually. Your instinct is, well, sure, why not? But let's see how this plays out. So, let's call it method A is the 3% and then the 5%. So if we do method A down here, they get a 3% raise. Okay, so that means that their new salary is going to be 31,000 plus 3% of 31,000. So let's see, that'll be 31,000 plus that 3% raise is $930. So after that first raise, now they're making $31,930. All right, now they're going to get another raise. The next time, we're going to take that $31,930 and they're going to get a 5% raise, 5% of 31,930. Let's see how that finishes out. So they're making the 31,930 plus whatever 5% of that is, 31,930 times 0.05, $1,596.50. And so at the end of the second year, right? So, you know, after the second year, they get this second raise. Now they're making plus 31,930. They are now making 33,526.50. So this was method A, where they got a 3% raise and then a 5% raise. The 3% took them here, and then the 5% took them to here. That's their new salary at the end of year 2. Okay, let's do method B here, which is just an 8% raise. So they started out making 31,000, and we're going to add 8% of 31,000. And that'll be 31,000 plus, all right, let's see what 8% is. 2,480. And we'll add that together. And they're making 33,480. So by method A, at the end of year 2, they're making 33,526. By method B, at the end of year 2, they're making 33,480. Not a huge difference, but it is different. The reason for that is this 5% raise was applied to their new higher salary. And so getting a little raise and then another raise actually took them to a bigger salary at the end. Getting a 3 and then getting a 5 isn't the same as just getting an 8, is the real moral of the story here. The reason for it mathematically is, the entirety of this 8% raise is based on the $31,000 salary. Over here, 5% of it is based on this $31,930, and that's why that ends up with a higher salary at the end. If you have questions on that, you can let me know. It's one of those things that Lorraine said it perfectly. Our instinct is, well, sure, a 3 and then a 5, that's the same as an 8. But it wouldn't be, because the 5 actually gets, once that 3 goes in place, that 5 is based on what your new higher salary. And so that's why that one comes out to be a bigger number at the end.